All right, we're going to take a look at the Practice 2425 worksheet. All 8 problems here. So in all of these, we are essentially solving for x in all of these geometry problems. But first, we need to officially discuss what is true geometrically before we get into the solving part of this. So given angle ADB, so we're talking about this angle right here, is 5x minus 10 degrees. And angle CDB, this other angle, and we don't know that they're the same, so I'm going to put 2 markings on it. So just to show that they are different angles, we don't know they're the same, but it's 4x plus 10. All right. Now, what do we know? We can start to try to think about what do we know geometrically must be true about these 2 angles. And again, we don't know any information if they are in fact congruent to each other, but these 2 angles are a special pair of angles. And they're a linear pair with each other, right? Together, they are adjacent to each other. They appear to be supplementary. Why are they supplementary? Because of the good old straight angle postulate. So the straight angle postulate is what's going to allow us to kind of pull together these geometric angles, and then we can make the substitutions to solve for x. So what do we always need to do first in our proof is we need to write our given statements. So here's what I'm going to do just to save a little bit of time, and I don't mind if you do this as well. You can say statement, you can just kind of drop down an arrow there, reason, given. Perfect. All right, now next up was we had to really figure out what was going on in this problem geometrically. And we said, hey, straight angle postulate's going on here. So angle ADB plus angle CDB equals 180 degrees. And again, the name of that was called the straight angle postulate. Now, some people might already want to go ahead and plug in those 5x minus 10 and the 4x plus 10 values for those angles, but first we have to start off geometrically. We are not going to mention anything about the algebraic expressions that those are equal to. But now we can make those substitutions out. We can substitute out for angle ADB. We know it has a value of 5x minus 10. We can substitute out the angle CDB for a 4x plus 10 equals 180 degrees. And we use the good old substitution property of equality. After that, we can combine some like terms over here. So 5x plus 4x makes 9x, and then the minus 10 plus 10 just cancel each other out. So anytime we combine like terms, we call that a simplify step. And last but not least, we can divide that 9 over to the 180 and get that x is equal to 20 by using the good old division property of equality. And we've solved for x. X equals 20. And so we're going to call that basically a done problem at this point. All right, number 2. Segment EG, so all of this is 4x plus 20. Segment EF, just this, is 3x. And segment FG, just that piece, 5x. All right, so again, we're going to, I'm not going to say cheat, but we're going to be a little lazy here. Just circle all that. That's all we would rewrite because it is the given information. Now, again, geometrically, what can we say must be true about these segments, EG, EF, and FG, ignoring the algebraic expression part for right now? And we can just use the good old segment addition postulate, right? That segment EF plus segment FG, 2 little segments added together, add up to equal the whole big thing, segment EG. So I will do some abbreviating in here. So seg add post for segment addition postulate. If you want to write it all out, knock yourself out. Some students have asked me, can I just call it the SAP? And I say no, because the straight angle postulate is also an SAP. So no, you cannot abbreviate that far. Now we can make our turn and say, well, what value is segment EF have here? And it is looking at the wrong one, 3x. Plus, we can substitute out segment FG for a 5x. And we can substitute all at the same time the EG for 4x plus 20. Now again, really I'm doing 3 rounds of substitution there, but I can do all 3 at the same time as long as they use the same reason, which they do, the substitution property. All right, next up, we can combine some like terms over here. We got 8x's all together equal 4x plus 20. So that was a simplify step. Meant to get a different color there. And then we can subtract the 4x over to the 8x and get 4x equals 20 by doing some subtraction. Property of equality. Now notice I do SUBT for subtraction as my abbreviation and SUBST for substitution. There is a huge difference between including that S and not including that S. And again, I've had students go, can I do SUBPE? And I go, no, because are you talking substitution or subtraction? So again, you got to give me enough of an abbreviation so I don't confuse it with something else. And then last but not least, we can divide the 4 over to the 20 and get that x is equal, if I can get that in equals, equal to 5. Again, with the division property of equality. And we're done with number 2. Number 3. We got lots of given information here. What do we got going on? Oh my. Not segment, that's array symbol. Ray LN, there's ray LN, bisects angle KLM. Okay. Then we're given some algebraic expressions for angle KLN, which is this angle, 15x, and MLN, the other small angle, 10x plus 20. Okay. So I'm just going to write those values in there. We will talk specifically about that bisect given statement. But again, very first step, all the things that were given to me. Now this is where it's really going to be nice just to circle all that and drop it down so you don't have to rewrite it all. But then now again, we got to start with geometrically what was so special in this problem. Again, we are not going to discuss the 15x or the 10x plus 20 right now, but just geometrically without those algebraic expressions, what do we know? And you may be tempted to use the angle addition postulate, little angle plus little angle equals big angle, and you could write that out. But we would run into a problem in the substitution phase because we don't have an algebraic expression for the value of angle KLM. Now what we do need to use was this piece of given information right here, that ray LN bisects angle KLM. That means this ray is bisecting this angle into two smaller equal angles. And those two smaller equal angles are, and this is where we're now going to jump in and say, we know angle KLN is equal to angle MLN. And how did we know those two angles were equal to each other? Well, we had a vocabulary word up here, bisect. And so anytime you have a vocabulary word, we need to define what that word means for us mathematically, or geometrically in this case. So definition of bisect. We knew that this little angle and that little angle had to be equal. Now we can make our substitution steps. So angle KLN had a value of 15x. Angle MLN had a value of 10x plus 20. So there's our substitution property of equality. Then we can subtract the 10x over to the 15x and be left with 5x equals 20. So subtraction property of equality. And let's see if I can get that different color now. Divide the 5 over to the 20 and get x equals 4 by using the division property of equality. And there's number 3. Number 4. Angle UVW and angle XVW are complementary angles. So they're saying UVW this angle and XVW that angle, that they are complementary. So just like in the last problem, in this problem we're given a vocabulary word, right? Complementary angles. And we need to talk about what does that mean mathematically or geometrically. And we're going to have to define what complementary angles mean mathematically. And then we're also given some values here, so I'll just go ahead and pop these in. So UVW, this is 3x plus 14, and WVX is 6x minus 32. Okay, so again, we're going to be a little lazy here, and that's okay. In some cases, there's all of our given information, or if you want to rewrite it all out, knock yourself out. But then, again, we need to figure out that geometrical thing. And so geometrically what's going on in this problem And you might go, well, it looks like angle UVX. That looks like a right angle. Looks like it's 90 degrees. But do you know it's 90 degrees? And really right now, no, we don't know it's 90 degrees. But what we do know is that angle UVW plus angle XVW, that they have to add up to be 90 degrees. And how do we know that those two small angles add up to be 90 degrees? Is because of that vocabulary word. So by the definition of, and I'm going to abbreviate complementary as just COMP, by definition of complementary angles, we knew that those angles had to add up to be 90. So it really is true that there's a right angle here, because together they have to add up to be 90, and that makes that big angle UVX. So if you want to put that 90 there, you can. It's not really necessary, but you can certainly put it there. All right. Now this is where we can make our substitution. So 3x plus 14 for angle UVW. We can pop in the 6x minus 32 for angle XVW. So there's the substitution step. And then we need to combine our like terms. So I got 3x's and 6x's makes 9x's. Positive 14 minus 32 gives me a minus 18 equals 90. That was just our simplify step. We combine like terms. Then we're going to add that 18 over to the 90 to get 98. And so we use the addition property of equality. And then let's see, last but not least here, we're going to divide that 9 over. Now 98 divided by 9. I'm going to say that I made a small mistake here. Oh yeah, I see my mistake now. Why didn't you guys tell me in the video? Why didn't you tell me that I only added 8 to 90 instead of 18? Geez, guys, you need to be louder in the video. Ugh. So this should have been 108. My bad. Okay, now this is going to make more sense here. When we take 108 and divide it by 9, and we're going to get 12. Okay, x equals 12 with the division property of equality. Math teachers make mistakes too, guys. I'm not perfect. I'll make little mistakes like that, just like you do. All right, number 4 in the books. Number 5. Now this looks a lot like the last problem, right? Like, oh, we got a little angle. This thing kind of looks like a right angle, but do we have that same exact setup? No, we don't. We don't know these are complementary angles. And we're actually told the angle PQT, that big angle, is 88 degrees. So it's almost 90, but it's not quite. And we're also told that this angle PQR is 4x plus 8. Angle RQT, the other angle, is 12x. And really, I could just use big O square, or not square bracket, squiggle bracket. And we can say all of that, there's the 88. So again, we maybe kind of see where this is heading, but we got to start off. Well, here, let me get a different color. There we go. We're going to take all of our given information, but then we got to write what's geometrically true first. And so some of you might already start seeing the angle addition postulate, but we're not going to do the algebra stuff first. First, we have to name it geometrically. So angle PQR, so that one little angle on top, plus angle RQT, the other little angle on the bottom, equals all together the great big angle PQT. So angle addition postulate. Now we can make those substitutions. So angle PQR, that was 4x plus 8. Angle RQT, that was the 12x. And angle PQT, that was 88. So we just did 3 rounds of the substitution property of equality. Next up, we get to combine our like terms. Altogether, we have 16x's plus 8 equals 88. So simplify. Next, we're going to subtract that 8 over to the 88 to get 16x equals 80 by doing the subtraction property of equality. And last but not least, and I've run out of room, so let me just scoot this up just a smidge. We can divide the 16 over to the 80 and get x equals 5 with the division property of equality. And we're done with number 5. Number 6. I is the midpoint of segment HJ. Then we're given a value for HI. We're given a value for IJ. So, number 1, let's grab all that. First statement, there's our given. What is geometrically true in this? Now, again, you might say segment HI plus segment IJ equals segment HJ by the segment addition postulate. And I would say that's true. I mean, that is absolutely 100% true, but you're going to run into a problem in the next step whenever you do the substitution phase, because we really don't have a value for segment HJ altogether. So the segment addition postulate, good idea, but there was something else more important in this problem, that I is the midpoint of segment HJ. So what does it mean that I is the midpoint of segment HJ? Well, it means that what's to the left of I and what's to the right of I must be the same length. So this is where we're going to have our geometric statement. We know that segment HI is going to be equal in value to the length of segment IJ. And how do we know that was true? Now, you got to make sure that you use the right word here, and you have to use the word that was given to you. It's by definition of midpoint. Now, I will say that over the years, I've had students write HI equals IJ by definition of bisect. And it's true that I is bisecting technically segment HJ, but it's not the term that was given to us. So make sure you use the word that was actually given to you. All right, then from there we can make our substitution. So segment HI we were told was 5x minus 8. Segment IJ was 2x plus 10. So there we're making our substitution. Next up, I'll subtract the 2x over to the 5x and get 3x. So subtraction property of equality, that's supposed to be an S. And then I'll add the 8 over to the 10. So 3x equals 18, addition property of equality. And then last but not least, we'll divide the 3 over to the 18 and get x equals 6 with the good old division property of equality. And there's number 6. Number 7. We got some supplementary angles here, so we're going to be doing some defining, and we've been given values for these angles. And I've got these kind of crisscrossed here. So let's start off. Hopefully you all are getting to the point where you're like, okay, I kind of see where this is going. I'm starting to see a pattern here. First we got our given. What's true geometrically in this problem? Well, we have supplementary angles, so what does that mean that they're supplementary? Well, it means that angle YZB plus angle AWC add up to equal 180 degrees. And we're defining a vocabulary word here, supplementary. Then we can make that good old substitution out. So this is YZB 16x minus 32 plus AWC 12x plus 16 equals 180. Good old substitution property of equality. Next up, we can combine our like terms here. So altogether we have 28x's. Negative 32 plus 16 is going to give me minus 16 equals 180. So there was our simplify step. Next up, we'll add that 16 over to the 180 and get 196. Not going to trick me twice there, guys. Nice try. It's not 186. And last but not least, we'll divide that 28 over to the 196. So 196 divided by 28 gives us 7 with the division property of equality. All right, number 7 in the books. One more to go. All right. Now this one kind of looks like a couple other problems that we've done. But notice in the given, there's some slightly different given information here. I'm telling you that this angle CDE, now it sure looks like a right angle, but can you assume that it's a right angle? We can't. You have to be told or given some other information that it's for sure a right angle, right? Like if I had put this marking in here, boom, you know it's a right angle. All right, so let's go ahead. Let's take that, let's drop it down. First statement, given. And what do we know geometrically is going on in this problem? Now, this thing has kind of two pieces that we need to do. Number one, we need to define our vocabulary word up here. So what does it mean that angle CDE is a right angle? Well, it means that angle CDE is specifically equal to 90 degrees by the definition of right angle. And I'll just use the angle symbol there. Okay, so that's kind of the first little part, but what's the main idea going on here? And it's going to end up being the angle addition postulate. So we've got little angle, angle CDF, that angle on top, plus angle EDF, that angle on bottom, all together equals, now here's where some people might go, equals 90, but we're not quite there yet. This little angle plus this little angle makes this great big angle, and we're still going to name that great big angle by its proper geometrical name right now, angle CDE. So that's what the angle addition postulate looks like. You have to name little angle, you have to name little angle, and then equals, then you have to name the big angle. The only time you can get away with not naming that big angle is if it was the straight angle postulate. Automatically it equals 180 degrees. All right, so now let's make our substitutions. CDF is 30x minus 12. Angle EDF, 18x plus 6, equals CDE. Now this is where we get to take that CDE equals 90 and we can substitute that value in. So we just used 3 rounds of the substitution property. Now we can combine our like terms here. So let's see, we've got 48 x's altogether, and then minus 12 and plus 6 gives me minus 6 equals 90. So there was a simplify step. Then we can add that 6 over to the 90 to get 96. So there's good old addition property of equality. And last but not least, we can divide that 48 over to the 96 and get that x is equal to 2. All right. So there are now finally all 8 practice problems. You might go, man, why did you give us so many? Because what we're going to step into next gets even tougher than this. We're going to get to a point where we're not even going to be solving for a specific variable. We're going to throw the algebra really out the window here. We're still going to use, in some cases, maybe some addition property of equality or subtraction property of equality. But it's not going to be in the same sense that we would use it algebraically. It's going to be more geometrically we're going to use those. So you will see very, very soon how this is going to get a little, it's definitely going to get tougher. I won't sugarcoat it here. The next section will definitely be a little bit on the tougher side, but we're going to kind of slowly go through it over a period of days, and I'll give you not very many problems to practice on, because again, I think you're slowly going to have to digest the next section. All right, we'll see you guys the next day.